today we're going to carry over with SOC Level 2 track from TryHackMe, and today's video will be about Atomic Bird Goes Purple number 1, which is a manifestation or practical manifestation of purple teaming. So today we will be learning the skills of doing purple teaming. And if you want to refresh your knowledge about threat emulation, purple teaming in general, you can take a look at this playlist where there are all the videos you can find that solve or provide the walkthrough for all of the threat emulation challenges. Okay, Atomic Bird Goes Purple number 1. This is part 1 of this room, and it contains a couple exercises where you will be able to emulate threats, okay, and then create detection rules, or in other words, examine the impacts of the threats that you have emulated. So you'll be playing both the red team and the blue team. That's why we call it purple teaming. It's a combination, or it's combining red team by emulating threats and blue team by examining the impact of these threats on your environment through log investigation. Okay, we have a machine that's attached to this room along with all the necessary tools. So how to approach this room? As you can see here, in task 2, there are the necessary commands, or the task 3 actually, the necessary commands that you will be able to, you will need to learn in order to solve this room. So we have the THM utilities, where you get to clear the logs and do other logs operation, examining the logs and so on and so forth. And here you have the Atomic Red Team usage, where you'll be able to emulate the threats as well as cleaning up the threats. Okay, that's for task 2, task 3. And for task 2, this is a summary of all of the threats we will be emulating, or the attacker's tactics. So we have system enumeration, input capture, command execution. All of these under the execution, discovery, and collection. Under lateral movement, we will be emulating data manipulation on shared drives, meaning we will be emulating how data can be manipulated and it changed. Collection, under collection, we will be doing data dump, clipboard, and system file modification. You can think of this as credential harvest. So as you can see, these are the tactics, attackers' tactics, and these are the actions. And based on the tactics that we will be implementing, we'll be examining the logs through Event Viewer to understand the impact, right? That's the blue team part. All right. So let's start with task 3. In task 3, use the required partial command to retrieve the flag. To answer this question, all you have to do is to go back to the THM utility usage, and here locate the THM log stats flag. Copy this, open the partial, paste this, and as you can see, this is the flag of this task. Okay, the other question: what is the required command to clear all generated artifacts and restore the affected files? Again, if you have been watching the previous videos, you will be able to answer this question without the help of the task. So we start with invoke atomic test. That's the basic PowerShell module we need to invoke in order to start threat emulation with the Atomic Red Team framework. So that's the basic command, and then we follow this by the name of the tactic according to marker. So T0123-4, and dash cleanup is to clean or to reverse the effects of the tactic. So the tactic, when it is running, or when you run the tactic, there are system changes and configuration changes that take place. In order to reverse these changes, you're going to have to use the dash cleanup. Okay, execute, investigate, detect. So on to this task. So in this task, we have 2 techniques: system information discovery and input capture, GUI capture. We're gonna emulate these two tactics from the attacker's perspective. And here, as you can see, the storyline, the purple team aims to simulate system discovery, meaning retrieving system information, GUI prompts, and command execution. And then from the blue team part, we're gonna examine the impacts and artifacts of system discovery by taking a look at the logs. So our task here is to run this tactic, T3041, to emulate or to emulate system enumeration. So that's the task. Maybe I'm gonna call it the code name of this of the technique according to MITRE. All we have to do is to use invoke atomic test, and then we follow this by the name of the tactic. Okay. If you want to have a look at this before you run it, which is very recommended, you can use -show brief, show details brief. Okay. So this looks like a custom emulation task. So initial enumeration emulation. All right. Let's show details. So here, this is the technique name, the test name, and the description: performing basic Windows enumeration. What are the commands used by the tactic or the atomic? It uses PowerShell to execute the command, and we have the full command. It's basically, it retrieves the system information, the updates, and send the output to a text file named task result. Cleanup commands: when we invoke the -cleanup here, it's going to execute this command to remove all the effects. All right, let's go ahead and execute this command. So executing this atomic test will create an output file. Let's have a look at this file. So indeed, there was a file created. Open up the file, we can see the system information, the host name, the OS name, and other details. So going to the question, what is the OS build info? Open this up again, and the OS build can be found here. This is the answer for the question. Execute test 3042. What is the flag? So the description of this test is given here. It is credential prompt emulation. On to the next question. Execute test T3042. What is the flag? So that's the description here. Credential prompt emulation. Let's go here and find what is the purpose of this. Before doing that, don't forget to do clean up. So here we're gonna do -clean up for the first atomic. We clean up or reverse the changes, clear, and then we execute the next test. -2, and we can use show details. Credential prompt emulation, and we can see the description. Atomic can be used to prompt messages and forms to fill out. So it's basically prompting the operating system, right, or the application to pop up forms, to create pop-up forms in order for the user to fill in details in hopes that the user would mistakenly input credentials, and the credentials will be sent to the attacker. And the executor is PowerShell. The command is, and that's the script. It's a PowerShell script executed under this directory. Now, if we go ahead and execute the test, let's see what's going to happen. Yes, so we get now a prompt. This is the input prompt. Now, when the user sees this prompt, they're going to input the username and password, not knowing that these credentials will be sent over to the attacker's server. For now, or for this task, we got the flag. We're going to execute a cleanup. Execute test T30-3. Let's see here. It's clear. And use dash show details. Okay, so the purpose here is to detect failed and suspicious commands. The command style process it uses PowerShell in a hidden window and executes bin bash. As you can see, there is a problem with this command. Okay, it's not going to execute successfully. If you try to execute this atomic, it's going to fail because there's a problem in the syntax here. As you can see, done executing test, but there is failed command execution. And that can be found from here. The names of the some imported commands from the module include unapproved verbs. Okay, yeah, so it's failed command. And this is the failed command, it's bin bash. Task 5. Let's do a cleanup here. And clear. Now, in task 5, we're going to emulate universal suspicious share. Replicate or replication through removable media. Purple team aims to simulate file manipulation actions on shared drives. As a team member, your task is to manipulate the shared files with given custom atomics. So the atomics here, the purpose of this atomic is to manipulate files found or stored in shares, removable shares. If you open up the computer here, we can see that there is a share with letter S. Let's navigate to this share. We are under this share already, dir. And as you can see, these files. To detect any manipulation of these files, we're going to have first to check on the integrity. To check the integrity, we're going to generate the hash. We can generate the hash by using a built-in module in PowerShell or cmd get file hash. Get file hash. The file in question is donation call, and this is the generated hash. The next thing we're going to do, we're going to see if the suggested atomic here will have an effect or impact on the integrity of this file. If the hash changes, we will be concluding that this atomic performs file modification. So let's go ahead and take a look at this atomic. Invoke atomic test dash show details. Okay. Description: performing suspicious file actions. What are the files or what are the actions? We can see the actions are performed by a PowerShell script. Okay, now let's execute this atomic. And now we're gonna examine the changes on the integrity of this file. How are we gonna do that? We're gonna execute get file hash. As you can see, the hash now ends with 990. However, before executing the atomic, the hash was ending with C1A, which means the integrity of this file was compromised, and we can see the new hash here. This is before and this is after. Okay, dump and go. Let's first perform a cleanup. Next task. In the next task, we'll be emulating clipboard data. Purple team aims to simulate storing command line history and hijacking system files for multiple aims, including MITM, Exfiltration, and Trick Security Product workflow. So here, I'm going to emulate dumping the history of the commands executed in addition to system file modification or exfiltration. And after that, we will be examining the effects of these two atomics by going to the or by navigating to the event viewer. First, let's take a look at the atomic. Dash show details. Data dump for exfiltration, and there's a partial script that performs the exfiltration. Now, if we execute this, probably it's going now to dump the history of the commands executed. Now, what's the question? Find the malicious history dump file. What is the flag? So there was a file created here that contains the history of the commands. We're gonna have to find the file, but basically this time we're gonna put on the blue team shoes and open up the event viewer. Okay, I'm going to Windows Logs, Security. Since we're looking for file-related events, we're going to filter here, create a filter, and event sources. We're gonna check Aura EDR. Click on OK. We have none. Okay, let's clear the log. Clear the filter. Okay, so here we're gonna have to find the file system events, or events related to file system changes. Basically, as you can see, the event ID is 4663. So we're gonna click on filter current log and use 4663. Let's take a look at the first one. Click on details. So the first one highlights a file under UpData named Analytics. Under General, we can see an attempt was made to access an object. Under the user administrator, check out the next one. Taking a look at the file, it's the same file every time, except this one is related to the file under the share. Maybe we can sort these events. Yeah, they are sorted in descending order. We want the most recent events. The most recent events related to file changes. We can see we have only the last three, or the last two. The first two events, they point to a file named Analytics. Let's copy the path and take a look at this file. Okay, THM logs that. As you can see, this file contains the history of all the commands executed under this session. These are the commands we executed to emulate the threats. It's clearly obvious. At the end, we can see the flag of this task. Let's copy this flag because I haven't solved the question before. Okay, now let's do a cleanup. Clean up. And it's very recommended to go back and clear all the logs. And let's clear the filter and clear the log, because we don't want cluttered logs every time we execute an atomic, right? We're gonna have to clear the logs from here. So clear, okay, and then we execute the next atomic. T000-2 -show details. The description says system file modification or system file modification for exfiltration, and there's a PowerShell script that performs this action. The job here is to execute the atomic and examine the effects in the event viewer. Okay, the question is, find the malicious system file modification activity here. Again, we are under the same category, file modification events. Now, having done the execution of the atomic, let's go ahead and refresh the event log. So here we can refresh, and we can see these events. As you can see, they are ordered in a descending, they are sorted in a descending order. You can start with the first one. As you can see, it's process creation. We don't want process creation events, we only want file system changes. Therefore, we're going to examine only the last two events. So this one, the file system that has changed, it is the host file. And in the second one, we can see the same file being spotted here. Let's take a look at the file. It is the host file, which contains information about the DNS mappings. Type, and indeed there is the flag. Copy this and you are done. Don't forget to do a cleanup. Dash clean up. And don't forget to clear the log. Okay, let's now go to the next task. Oh, there is no next task. Okay, so it is all done now. Alright guys, so that was it.